So my name's Trevor Bodz. I work at IBM, developer for probably about 15 years, and now moved into the product management side of things. When I was in development, my kind of goal for myself, and then when I moved into managing my team, was really how can I make teams more productive. When I sat and looked at my team, they were probably spending about 30% of their time writing code and 70% of their time doing a bunch of other stuff. And now that I've been on the product side, anyone I talk to, it's anywhere from 30 to 50% of their time. Their estimate is that's the time their developers are spending either playing with servers, setting them up, configuring them, tweaking them, and a lot of times setting up their runtimes as well, so either Java or Node and so on. And so I was given the opportunity to kind of take the lead on IBM's serverless platform that we are in the process of developing, and that went live in February. So I'm curious, how many people have actually heard of serverless programming or architectures before? Okay. So a little under half the room. So I'm going to kind of talk today. Hopefully you'll get to learn what serverless is, some of the times it's good, some of the things it's not good, and then talk a little bit about OpenWhisk, the offering that we have from IBM. Hopefully that'll be the shorter part of the talk, because I know not everyone loves vendor pitches. So I like contrasting kind of the traditional way of doing things. You have an idea, you want to come up with the next billion-dollar startup, you are going to be the next Facebook or something, and so you're going to spend weeks or months writing your code, and obviously you have code and microservices, and you need a bunch of servers to go and run those things for you. And so you want to get that out to the door as fast as you can so that you can get feedback from your users, iterate, and kind of keep doing that cycle as fast as you can. But servers always let us down. Something always goes wrong. A hard drive fails. We find out a couple weeks in that, hey, now I have a Linux OS problem that I need to go fix. There's middleware updates. Your site goes down. Clients have nothing to go and look at. And so a bunch of you are probably thinking, hey, we're doing microservices. So we've already figured that out. We've had a monolith that we started with. We've broken it down into microservices. We've kind of taken the next step, and we've made them all HA. So they're all highly available. So if one microservice goes down, no problem. We got another one there backing it up. And few of you probably have even gone farther on our Netflix, and it's like, hey, we even got that figured out. If the whole data center goes down, we've got another region where we can switch over to, and everything's going to be great. And so by doing that, you kind of add two new problems to yourself. Yeah, your app's going to be there. Your services are going to be there the entire time for your users. But now your infrastructure costs are probably going to start shooting up through the roof. The more and more microservices you have, the more servers you probably need. And it's kind of interesting to see how that trade-off balances out. Obviously, you want to keep costs down, and so you try and cram more things onto a single server. But now you're kind of getting back to that monolith. And then operational complexity. You have a pile more things running, and obviously you need a much bigger ops team to go and handle that for you. In July of 2013, I think it was, Google put out a report, and one of the numbers that they had in there is that they looked at over 20,000 clusters that they run over 3 months, and they were 20 to 40% used. That means 60 to 80% of the time those servers were sitting there idle, which means you're paying for resources that you're not using. Basically, it's like you brush your teeth and you leave the tap running. It's just water going down the drain for you. And so it's kind of, depending who you talk to, I think everyone agrees that's one of the big draws of serverless, is that you don't have to worry about that. And so over the last 10 years or so, we've kind of seen an evolution happen where life, I believe, for developers has kind of gotten easier when you look at servers. So we start off with bare metal, and a lot of people think of those as pets. And so my first job, my servers were named after the planets. We ran out of planets, and so we moved on to moons. And then DevOps kind of moved in once we started getting to virtual machines and containers, and we started thinking it's like we no longer have pets, we have cattle for our machine. They should be interchangeable, replaceable. Container dies, just throw another one up there. And now as we've moved to platform as a service and functions, a lot of people are more thinking of this is a herd of cattle. You don't even really care about cattle that you have. It's just there's a whole herd of cattle out there that you can start using. It's more of a utility like an electricity company. Electricity is always on there for you. It's up to you if you want to use it or not. And so really, depending who you talk to, serverless functions as a service, there's actually an interesting blog circulating around that, just call it Jeff. In the end, it's really about the value and not about the name. A lot of people don't really care for the name serverless because, hey, the big punchline, there are servers. They're just not your servers anymore, and you don't have to worry about them, manage them, and upgrade them. And so really now, your microservices come down into a very smaller unit of deployment. You are now basically deploying a function, a discrete little piece of code that usually does one thing and does one thing very well for you. And so in its essence, that's what serverless gives you. But that then comes with its own problems as well, but a lot of benefits. And so I think there's two benefits I want to talk about. One is scaling. And so for those not familiar with it, basically what most of the platforms do is in some way or form, either via CLI or a web UI that they have, or REST APIs, you upload your code to their platform. And it sits there and waits for an event to happen. And so an event could be a change in the database, maybe a change, something's been added to object storage, or an API call, so you can hook them up to API gateways. Instead of having it hit a microservice, your API now just routes to this single function that happens. And so basically, when an event happens, we'll grab your code, put it into a container with your runtime, and execute it. And so you're probably thinking, it's like, well, great, I have one instance running. Now what happens if another call comes in, I need to do another one? That's the beauty of serverless, is that you get infinite scale. If you have 1 or 1,000 of these requests coming in, that's, again, abstracted away from you. That's the less part of serverless. You don't have to worry about that. When you're looking at platforms, there's kind of two pieces to look at. So let's say you have a request that comes in, it's done processing, and then another request comes in 5 or 6 seconds later. Companies are pretty smart that they'll actually keep that container around for a little while, and this way they can reuse it. It's your container with your code. If they need to run the same thing, it's there. And so these things usually start in the order of milliseconds, definitely less than 10 milliseconds for your code to actually start executing again. And so everyone calls that a warm start. On the opposite side, there's a cold start. So it's like, hey, you haven't had something that's run for an hour. So maybe it's a scheduled job that runs every night. Maybe it's an export that a client asks for. It happens fairly infrequently, and so it's a cold start. And so again, it means you have to fetch your code, get a container, get things up and running. And so usually you're looking at tens of milliseconds, almost always less than 100 milliseconds in startup time for that. Really depends on you and how you architect your code. So obviously the more lines of code, the longer it takes. If you're using Java and you start pulling in a whole pile of libraries and you have this large jar that you're giving, obviously it takes a lot longer to start things up. And so as you look at all the platforms that are out there, those are kind of two kind of important things to kind of look at of, hey, what language are you using? And we've seen a lot of best practices where people are recommending less than 100 lines of code per function. Keep them small, discrete, and do one single thing and one single thing only. And so that one function that runs fairly infrequently, that doesn't sit there, that's another one of the beauties of serverless, that it's pay as you go. If your code's not executing, you don't pay for it, and that's the end of it. And when your code does execute, that's what you pay for. And so if you write efficient, performant code and it runs really fast, you pay for that amount of time that it runs. It could be milliseconds, it could be seconds. And almost all platforms charge in increments of 100 milliseconds. They just round up to the nearest 100 millisecond for that to go. And so I think this is where a lot of people have seen a lot of benefit, but I still think there's a lot of work to do before you actually think about adopting serverless. And so there are a lot of blogs out there where there's one company that did log analysis. And so basically, they were just waiting for logs to come, and when they would get dumped into their system, they'd have to process them. And so almost all their time was sitting and waiting. And so their estimate was they saved 80% on compute cost. I was talking back to a startup in Austin last week. They have 1,000 clients. Their compute cost on AWS Lambda is $56,000 for a year. So if you think back to 10 years ago when you probably had to go build your own data centers, huge savings. And so I think the piece that's missing out of here is everyone always talks about compute costs. No one really talks about the manpower or the upside of it. And so one customer that we've been working with decided that some of their stuff doesn't make sense for serverless. Right now, they're running at about 2,000 API calls a second. By the end of the year, they're expecting 10,000 calls per second for this one API, and their plan from 2 to 5 years from now is 50,000 calls per second. So when you start doing that math, they said, we already have an ops team, we have a bunch of VMs. It's not going to kill us to add a few more VMs to run this load, and so we're fine with not doing serverless. And so I think they didn't really factor in that, yeah, they have the ops teams. Ops guys are hard to find, great ones. They're not that cheap. But then also, what is the productivity cost to your developers? Really, these serverless platforms, you load and go. You write your code, you upload it, and that's it. You click a button, it's live, and it's done. So providers. As the talk this morning, all the 4 major cloud providers out there, Google, Amazon, Microsoft, and IBM, all have some flavor of a cloud platform. There's a few startups out there as well. Iron.io seems to be one of the bigger, more common ones. And so, again, as you pick your providers, there are lessons to be learned. So everyone's always afraid of vendor lock-in. So these are execution platforms. They're not really the full application suite that you need to deliver. So that means you probably need a database. You probably need object storage. The list kind of goes on for services that you need. And so once you start implementing, you're dependent on someone's set of APIs. Amazon's are different than IBM's, are different than Google's. And so depending on who you choose and the path you go down, there is potentially that vendor lock-in. Analysts are starting to get in on this as well. And so Gartner released their hype curve of 2016. And so coming up kind of right in the beginning now is serverless. And their projection is pretty soon that people are going to run into struggles and kind of hit the trough of disillusion. And so I think right now it's just that these platforms are so immature. I think Lambda started off in 2014 and everyone else quickly caught up shortly after that. But it is very brand new. It's still a very long way to go with them. So some of the struggles and other things you should worry about is compute limits. So these aren't great for things that are long running. Everyone has a cap of some sort. The average seems to be about 5 minutes of execution time. So if your code runs for longer than 5 minutes, it's just going to error out, and you're going to get an error message back, and that's kind of the end of it. They all have memory limits. So I think probably the average out there is 1.5 gigs for your memory. And so it's good that it's customizable. One person that we've worked with does exports. And so when they export PDFs, they give it a 1.5 gigs because they're very memory intensive. When they export the same data out to an SVG, they give it 128 megs to save money because it's a lot quicker. But you really need to worry about that. Another one is concurrent processes. And so kind of as a safety net, a lot of them have some limit that you can run only, say, 1,000 of these functions or actions at a time. After that, they start erroring out. And so there have been times where people have actually done a denial of service on themselves without realizing it, that it's per an account. So if you have an Amazon account or an IBM account, you can run 1,000 at a time, and usually an account will have your dev environment and your production environment. And so if you screw up something in dev and all of a sudden you're spinning up a bunch of these by accident, then obviously that's going to impact production too. And so then it kind of gets into interesting account management problems as well. I think for developers, the biggest struggle right now is the set of tooling that is around serverless. Because serverless is so new, tools just haven't caught up. And so I think 3 big ones for me are debugging, testing, and monitoring. So with debugging, you don't have an environment that you can log into. There is no box you can SSH into to go and test your code, which means there's no remote processes you can go and debug. You have nothing to attach a debugger to. And so that means it comes down to logging. And so you better do a great job of dumping things into your logs so that you can go back and actually see what was there and what wasn't there. Local development is also hard on most platforms because it's a cloud platform. You upload your code and away you go. Testing gets a little interesting that there are actually now a lot of frameworks that are popping up for this. And so unit testing is actually getting pretty decent. There are some interesting ways of doing it. People have done it of, hey, I'm going to write a function as a service. I'm going to write a function to go test my other functions, which to me kind of defeats the purpose of pay for what you use, because obviously you're now running more and more functions against that. Integration testing starts getting really hard, though. So at this point, you've offloaded everything to your platform. And so that means how do you now start testing with all these third-party APIs, your online database, and everything else? You have nothing on your data center. That's nothing on-premise. And no one's really figured out how to do a good job of integration testing. And monitoring is just starting to catch up. So I think last week or 2 weeks ago, Datadog is the first one I actually saw for kind of a third party that actually will pull data in and actually let you do some monitoring alerting on that. And so I think it was in July, Amazon Sydney, there was a huge storm, backup generators didn't kick in, the entire data center went down. And so if you think about these, think about serverless, everything is event-driven. Your code is waiting for an event to occur so that it'll execute. So if your data center goes down, in this case, Sydney, then you really have no idea that your code went down. And this is a problem that all vendors have right now of there's no VM or container that you can go and put an agent on to monitor of, hey, is my thing actually up and running? There are a couple frameworks, but there's still a very long way in going for deployment. So a few people have stated that there is no ops in the DevOps portion of serverless. There definitely is. You still things will go down. You still need people to monitor, alert, debug, and troubleshoot. But the CI/CD part, I still think is a good way to go. So if you think about building your microservices, there's a bunch of code all put together and deployed out. Where here, people are now getting into the tens, hundreds, and thousands of functions because they are discrete little blocks that you use. So trying to deploy all of that, you might have a function that is used by 3, 4, or 5 different applications. So how do you version that and then make sure you deploy out the right version to the right set of applications? So I highly recommend if you do start your serverless journey, pick a framework. The first one that was out there was Serverless. The serverless framework, and then Apex followed, and then not for this room, but Zappa if you are a Python developer, if you have Python in your shop. They make life a lot easier setting up API gateways, doing deployments, rollbacks. They have a lot of great skeletons and frameworks out there as well. So if you definitely, as a developer, I highly recommend do some look into frameworks and pick one of those. So some of you that have been doing cloud native might be wondering, well, isn't this just platform as a service by now? They sound pretty similar. And so this is my kind of favorite tweet from Adrian on this note, where, yeah, if you can spin your things up in 20 milliseconds, have them run and shut down, then call your platform serverless. But I haven't seen anything out there, Cloud Foundry or other, that is capable of doing that. You still stand up something, it's an app instance, it runs, it's there forever, and it doesn't kind of grow on demand for you. It does auto scale, but again, you're paying for something that may or may not be used. So this brings me to one of the platforms, OpenWhisk, which is IBM's open source platform, which basically, as I've stated a few times, it executes code in response to events. And so one of the things that's interesting and unique about OpenWhisk is that it is open source. It's the only major cloud platform that is 100% open sourced. So IBM, we're actually here with the OpenTech team, is very big about open for the enterprise. And so that means you can actually go and grab the code and run it locally if you want. We've actually had people, we have a Slack channel out there, and so we've actually had people pick up OpenWhisk and they're running it on Amazon. So yeah, the one guy's laughing. Sometimes someone asked this question, I'm like, hey, we're trying to run this on Amazon. Can you guys help us? We're like, sure, it's open source. Like, as long as you guys can help us work through some of the problems, we'll gladly get things up and running. And so we do have a UI. There's a CLI, so depending on what type of developer you are, there's a web editor, which I think those web editor CLIs are standard across all of the platforms that are out there. And OpenWhisk kind of comes down the programming model to kind of 3 kind of concepts. So actions, which are your functions, that's where you just go and write your code. And so basically, you write stateless JavaScript code, and that's also one of the kind of caveats that if you've never written stateless, it's a different and interesting way to kind of think about writing your application, that this container runs and then it's gone. And so if you need to transfer state, then income databases or other things that you kind of need to now worry about. We also do support Python, Swift, and we're the only platform that supports Docker. So if you have some languages, Scala, Go, and other, which aren't supported by any of the platforms out there right now, you can actually package up your code into a Docker container and give it to us. And every time you want to execute it, as an event happens, we'll actually run your Docker container for you. So removing some of that orchestration problem that you have. So here's just kind of a simple thing. So for what us and all the platforms need is we need a main and a return. The rest is really up to you. And as of about a month ago, to the best of my knowledge, we're the only platform that supports Node 6. A few people have jumped up to Node 4 in the last few months. We kind of skipped that and went straight to 6. Triggers is the kind of other fundamental piece. And so as events come in, trigger is the thing that calls your code. So an event happens, I need to have my code execute it. And so we built OpenWhisk in a way to have things reusable. So basically, you can build a library of actions and a library of triggers and have them independent of each other. But then we have the concept of rules. And so you can actually now start stitching these libraries of things for reuse. So maybe you have an action that'll post something to Slack. And now you have 10 different GitHub repos. And so those are all different triggers linked to each repo. Instead of having to rewrite that code for, hey, I want to post to Slack, you can just create 10 rules and reuse that same piece of code that you have. And so, as I mentioned, I was a developer, and being at Node, I was guilty of being a Java developer for 10 years. And And so all I knew was servers. DevOps was kind of new at that time. And so servers, the headaches with them and all the problems they brought, to me, that was just my normal life. And this kind of picture sums it up. I'm like, yeah, that's fine. I'm like, that's what I knew. I didn't know anything better. But I challenge all of you guys to go figure out what use case works for you guys. I challenge you to burn your servers, take that idea that you have, and really upgrade your productivity as developers. There's definitely some use case in every company. A lot of people I've seen have kind of started with kind of scheduled or batch jobs that don't run that frequently. They just want to offload them to a system. That might be a good place for you guys to start as well. So that is my 20 minutes. I am going to be at the booth after this. So if you do want to see a demo of OpenWhisk, learn more about serverless, it is my passion and something that I love, then come on by. And with running behind, any time for questions? I don't know who I should be looking at. Until they kick me off, any questions?
Yeah, I've been looking at Lambda,
Mm-hmm.
and I've had a problem with running a web application via an API. Wants bits from your server.
I guess. So if it's a webcast, if I can't hear you, then they won't be able to hear you.
Okay. I've been working with Lambda a bit, and I was struggling with having a web app, calling a server, calling an API. And for example, with long polling, also, you want updates from your server to propagate to your app or to your website. So, do you have a solution for that? Because you're charged by the 100 milliseconds. What do you think about that?
So what was the question again? Sorry.
On Lambda and OpenWhisk,
Yep.
you're charged by the 100 milliseconds.
Yep.
So if you're a lot of web applications also do, for example, long polling to wait for new data on the server. So if you're doing that on OpenWhisk and being charged for per 100 milliseconds, then every time a user is online, it's constantly being charged because and you hit the 5-minute limit. So how do you propose to solve that?
I guess instead of kind of polling and waiting for data, Amazon and us, you can create your own custom event sources. And so basically you should be able to go and create an event source saying, hey, a new event has happened, go and run this code. So that should remove the polling portion of it.
Yeah, but it needs to go to the browser.
Yes.
And so you need some way to subscribe to events from the browser. And then, of course, server sides you can initiate a function. But that needs to propagate, some notification or something like that. But then integrate it in an API.
Yeah, I haven't seen anything done like that yet.